It's widely believed that sex is determined through sex chromosomes, namely the X and the Y. And this is true in many species, humans included, but it's not the entire case. Notions of a sexual binary need to be dispelled in order to understand the nuances of sex determinations, according to Devlin and Nagahama. In this presentation, I will explain genetic sex determination, GSD, environmental sex determination, ESD, and I will dispel notions of a sexual binary by explaining disorders of sexual development, or DSD. Now, genetic sex determination, GSD, typically involves specific sex chromosomes to produce gametes, or sex cells, like sperm and eggs, and this is true in many mammals. You have the X and the Y chromosome, with the heterogametic sex, meaning they have the X and the Y, being males, and the homogametic sex being females. Now, many people say that the Y is a sex determination chromosome, and they're kind of right, but not really. It's mainly the genes that are on the Y chromosome, according to a paper in 2014 by Bachtrog and colleagues. Because the Y chromosome contains the differentiation genes that allows for the full development of the individual. And as we can see here in this image, the amount of information stored on there varies greatly throughout the animal kingdom. Now, X and Y is not the only system that we can use here. Many species, like birds and butterflies, use a ZW and a ZZ system, where the heterogametic and the homogametic sexes are switched, with females having the ZW chromosomes and males having the ZZ. In invertebrate species, it gets even more complicated, like flies and worms. They use the ratio of their autosomes, or their non-sex cells, or chromosomes, to their sex chromosomes. So in flies, you can have an X0 genotype, where they have no Y chromosome at all, yet they still develop as male. However, they're sterile. This is because they don't have that SRY region to differentiate their sex. In worms, like C. elegans, a ratio of autosomes to sex chromosomes of 1 or 0.67 produces hermaphroditic females, meaning they are structurally female, yet they produce both gametes, and a ratio of 0.5 to 0.75 produces males. It's now at this point I want to define my terms that I've been using here: sex determination and sex differentiation. Determination is the developmental decision whether or not to produce gonads, or which ones to produce, I should say. And differentiation is developing the hormones that are produced by that, like testosterone and estrogen, according to a 2012 study by Eggers and Sinclair. However, genetic sex determination is not all there is. There's also environmental sex determination, which most reptiles use, according to a 1997 study by Siafi and Swingland. Now, it can be seen here on this graph that most lizards and crocodilians use temperature-based sex determination. So most lizards and crocodiles produce, at low temperatures they produce females, and at high temperatures they produce males. Most crocodiles produce females at high temperatures and males at low temperatures. While all three of them, turtles, lizards, and crocodiles, produce females at the extreme temperatures, be it high or low, and males at the moderate temperature. However, temperature-based environmental sex determination is not all there is either. Some species, like the green spoonworm, determine it by the sex ratio in their proximity, where if they settle by themselves, they develop as females, but if they settle near females, they turn into males. Some species take it even further by determining their sex on the length of day. In some species of brackish water shrimp, males are produced on long days and females are produced through short. Now that we understand some more about sex determination as a whole, we can talk about what happens when it goes awry. This graph picture here, from a study by Rothkopf and John in 2014, shows the three categories of disorders of sexual development. You have the sex chromosome disorders, and then you have the 46XY and 46XX disorders. Now, the sex chromosomes, DSDs, affect how the individual develops. It determines what gonad they develop. So this is where you see stuff like extra chromosomes or less chromosomes, like 47 or 45, and where you get things like Klinefelters and Turner syndrome. 46XY and XX are differentiation rather than determination disorders. So these are going to be your big hormone imbalances or your less determined genitals and such. It is also stated in that same study by Rothkopf and John that people born with disorders of sexual development can number as many as 1 in 300, which is more than 1 million people in the United States alone. So I hope, or I'm going to leave you with this last picture here, where on my left here, you can see this chicken, which is perfectly split down the middle, with one side being ZW and the other side being ZZ, showing a complete sexual dimorphism right down the side. And on the other side of that, you'll see a kangaroo here, a male kangaroo, which happens to have a pouch, which is a female trait. So many of these individuals can develop completely normally and have a normal life, despite being genetically different from most other people. I hope throughout this presentation I've been able to explain to you that sex is not as simple and cut and dry as an X and a Y.